Yes, we are.
Okay, indefinite integral of f of x with respect to x, what does it mean? What's the thing that your answer is going to tell you?
Antiderivative.
It's an antiderivative, but right, what we're looking at is, yes, it's the antiderivative, but what makes this so special, the reason why we call this guy the antiderivative is that when you take the derivative of f of x, of big F of x, what do you get? Little f of x. This is why we're having conversations about dancing backwards. Now, I like this, but I don't love it.
Plus C.
Plus C, right? And like Miss Blakely always calls it plus Charlie. And the reason why we want to talk about C, this constant of integration, is that now we're not talking about one function, we're actually talking about this family of functions. The family's last name is big F of x. The first name of the member of the family is whatever the constant happens to be. I don't know that that analogy goes as far as I wanted it to. All right, so there are probably like 20 integration rules that you need to know, that you need to just memorize. And I think a bunch of them you probably already do because you guys are accomplished dancers in the forward direction, and so now it's just time to dance in the backwards direction. So you've got 3 minutes. There are 13 integration formulas up here that I want to expose you to today that you are going to have to get memorized. You need to know these on sight so that on like, the sticker challenge that happens on Thursday, you're ready and you're set up for success. Carmen, you look like you're having cramps. You okay? Yeah. You're like, whoa, sticker challenge. You always get all the stickers. You're going to be fine. So you've got 3 minutes. I want you to work with somebody you are not currently sitting with. This is a standing up only conversation. Don't anybody sit down. Your job is using your smarticle particles. Tell me as many of these as you can. Ready, set, go. 3 minutes. Don't sit down. Don't sit down.
First one is nx to n minus 1. Second one is the next
I'm not sure, but I will be. Do you leave after school?
The second one is next.
No, it's just maybe. I'm going to be leaving here at
Third one
2
is
o'clock to go to Colton.
Okay.
I just want us to spend a little bit of time talking. You don't have to get all of them. Get as many of them as you can. I think. Yes. Oh. Giselle. Where'd my Giselle go? Giselle.
negative e.
Carmen. Palomon.
No, yeah, it is.
Myra.
And this is.
Steven.
This
And
is.
Carmen.
Literally,
Wouldn't it be like?
So e to the k.
That would be
Wasn't it negative x
negative e.
to the negative x? Or was it the opposite?
Negative both sides. Yeah.
Here, let me do this real quick. A is a constant. So you bring it down, right?
Alrighty, why don't you guys have a
Oh, wait,
seat?
no.
And we've got 13 formulas, 11 of you all. Everybody's going to have to share at least one. You want to get in while the getting is good. Let's get some hands on this. Anyone that you see that you know for sure. Celeste, get in there.
The first one, n x to the power of n minus 1.
X to the power of n minus 1?
No, n times x.
N times x to the n minus 1. So for example, if I said integrate x to the 4th dx, what would your formula tell me?
Plus 1.
Right, your formula would tell me that the antiderivative is 4x cubed. Sadly, not so good.
Oh, yeah.
And I heard you say that one right off the bat, and you took other people down with you. You can turn that off. Andrew. Oh, sorry, Mr. Link. Andrew, any one that you know for sure.
5 is negative cos plus c.
So the antiderivative of sine of x is negative cosine of x plus c. Love it. David?
6.
Number 6.
Yeah, sine of x.
The antiderivative of cosine of x is sine of x plus c. Love it. Giselle?
Number 2 is the natural log of x plus c.
The natural log of x plus c. Now, here's the thing I want to get right. You are 100% right based on what you know so far. Because you know that the derivative of the natural log of x is 1 over x. However, when it comes to the natural log function has a problem. It has domain restrictions. You can only take the natural log of natural log of positive numbers. Everybody okay with that? So and over here there's no restriction that x has to be positive. So the antiderivative of 1 over x is actually the natural log of the absolute value of x. This is going to be something we didn't worry about in the forward direction. It's a reverse direction kind of thing. And the problem is there's no domain restriction here other than x can't be 0. And I need to make sure I have matching domain restrictions on my answers. Giselle, that was yours, right? Okay. Next. Carmen.
4 is 1 over x plus c.
Okay, 4 is 1 over x plus c because we know that the derivative of 1 over x is negative 1 over x squared. Nice. Stephen.
Number 3 is square root of x plus c.
Okay, number 3 is the square root of x plus c. I agree that the antiderivative of 1 over 2 square roots of x is square root of x plus c. Lots of other ones. Myra.
Number 7 is e to the power of x.
Okay, e to the power of x plus c. Love it. Okay, Eileen.
I can do times.
Okay,
Cosine.
cosine.
Cosine of k of x.
Cosine of kx.
1 over k.
Celeste,
Negative
okay.
cosine.
Okay, first of all, definitely negative cosine. I don't love this answer. There's a problem, and it's, think about the derivative, think about what happens in the derivative. In the derivative process, you would say the derivative of negative cosine is positive sine, angle stays the same, and then
Times k.
you'd multiply by the constant. In the reverse direction, what you're going to have to do is divide by k, or say negative 1 over k, cosine kx plus c. Okay, fine, my last name is written up for you. Any other ones that we know for sure? Lewis.
11 is it sine of k of x
Sine of kx
times 1 over k.
times 1 over
Plus
k
c.
plus c. Is everybody okay with why this 1 over k is showing up? We're 100% with this. Think about chain rule. Chain rule says this is a constant, leave it alone. Derivative of sine of stuff is cosine of stuff times derivative of the stuff. So you get a k on the outside, you need that 1 over k to sort of cancel each other out. Is that Lewis? Okay, Paloma.
9 it's 1 over k times e kx.
Okay, 1 over k, e to the kx plus c, love it. Oddly enough, we're all staying so far away from number 1. No one wants to touch number 1. No one wants to touch the power rule. Okay. Have a conversation with someone near you. What is the antiderivative of x to the 4th with respect to x? I know you know it. What's the antiderivative of x to the 4th?
1 over 5. 1 over 5x.
The antiderivative of x to the 4th is
1 over 5 times
1 over 5
x to the power of 5.
x to the power of 5. So you started with x to the 4th, and your antiderivative is 1/5 x to the 5th. Can some brave soul tell me then, what's the general rule here for x to the n? What do you do? Lewis, what do you do?
Is it 1 over n plus 1
It's going to be 1 over n plus 1
times x to the n plus 1
times x to the n plus 1
plus
plus c. You had, Celeste, you had like some of the pieces going on in there. But you've got to keep in mind, what do? You add 1 to the power, and you divide by the new power. That's what the power rule says. All right, and for some reason, no one's talking to me about number 8. Antiderivative of e to the negative x. Solomon, what you got? Negative e to the negative x plus c. Nice. Okay, and no one's touching 12 and 13 here.
Oh,
Celeste, get in there.
oh wait.
The one on the left is tangent of x.
Okay, the antiderivative of secant squared of x is tangent of x plus c. I completely agree, right? Because the derivative of tangent is secant squared. Now, do we know something that has a derivative that is secant of x times tangent of x?
Yes.
God, if only there was like this green sheet that summarized everything.
Secant of x.
What would you take the derivative of to get secant of x times tangent of x? Secant of x. So secant of x plus c, and I'm such a good teacher, I think I'm going to eat this one myself. All right. Is everybody mostly okay? For my flashcard people, I think it would be a good idea to turn some of this into flashcards. I also have one little story that I wanted to share with you guys. I don't know that I ever shared this with you, and if I did, let's pretend I haven't. And Stephen, can everybody over there? A couple of years ago, I was in Pasadena doing a PD session for students, and I saw somebody write this down on their paper. And because I was in Pasadena, I was convinced gang sign. Right? I was like, oh my God, we got gang members, we've got like South Side, Crip killers, I'm not sure. It was really scary. And then I saw it on somebody else's paper, I was like, oh, they're in the same gang. Then when I realized they actually all went to the same high school, and they had a teacher who gave them this as an easy way to remember some stuff. Anybody see it?
Well, sine code.
S, C, negative S, negative C? What is this?
Sine, cosine.
Sine,
Derivative of.
cosine, negative sine, negative cosine. The reason that the teacher gave it to them, what do we know going in this direction? This is the derivative. So the derivative of sine is cosine. The derivative of cosine? Negative sine. The derivative of negative sine? Negative cosine. The derivative of negative cosine? Sine. And they had that, they were like, had it on lock. They're like, derivative of sine is cosine, derivative of negative sine is negative cosine. I was like, oh my God, that's so good, because now you also know in the reverse direction, and they just blinked at me. They're like, what do you mean? And I was like, if you know the derivative of sine is cosine by this little thing, what else do you know? The antiderivative of cosine, when you go in this direction, we're doing like integrals, we're doing antiderivatives. Completely blew their mind. They're like, wait, it works that way too? Like, yes. So the derivative of sine is cosine, derivative of cosine, negative sine, derivative of negative sine, negative cosine. But if I said, hey, what's the antiderivative of sine? You guys would all tell me?
Negative cosine.
Okay, that sounds like Celeste just... The antiderivative of sine is negative cosine. And Carmen and Celeste sound nothing alike. And the antiderivative of negative cosine is negative sine. And the antiderivative of negative sine is positive cosine. Everybody good? All right, so tonight's homework, two things, because sadly I'm not going to see you tomorrow. You guys have the senior service thing? So, thing number one, well, no, I won't be here. I'm going to be working on unit plans and unit exams. So, oh, that's exactly what I needed.
Can I be there?
No, I'll have to see you on Saturday. That's enough. All right, so homework tonight is assignment number 88, which is practice with integration. I'll say that one more time. Homework tonight is assignment number 88 in the problem set packet, all the problems. Not all the problems in the problem set packet, all the ones on the paper that says assignment number 88. In addition to that, the test, corrections, and reflection for Unit 5. I want to spend the next 20 minutes or so giving you guys some practice time with integration. Integration is just one of those things. You're going to get this under control by getting a good amount of practice. So I want to give you some practice time. At 9:25, we're going to stop wherever we are. And those of you that had some struggle places on the unit test, we're going to move to one side of the room and get some support. Those of you that did well on the unit test, you guys are going to get an opportunity to start on the homework already. Okay, so here's what I want you to do. In the student handout packet, there are 1, 2, 3, 4, 5, 6, 7, 8, and then I think 2 more problems at the top of the next page that I think you guys should be able to do pretty successfully without a lot of support from me. Your goal in the next 8 minutes is get as many of these done as you possibly can. Use your notes. Check in with folks that are around you. And then we'll do some hard ones.
You guys?
Mine's in my locker. I can't go there right now. So get mine.
Okay, so you're going to get this to me
Next to you.
next period.
Yes. I have
Nothing to say there. David, homework.
Yes.
Although I'm not requiring the check step, it may not be a bad idea to check your answers from time to time. All right, so if all goes well on the first one, antiderivative of 4x cubed is x to the 4th minus x squared plus 7x plus c. Pretty good? Number 2, antiderivative of t to the 11th power. Well, that's that power rule where you add 1 to the power and you divide by the new power. So 1/12 t to the 12th minus antiderivative of t to the 8th is 1/9 t to the 9th minus the antiderivative of t. What would you take the derivative of to get t?
1/2 t.
Minus 1/2 t squared. If you didn't see where that came from, think about that as t to the 1st. And then here's where you got to be careful. What would you take the derivative of to get square root of 7?
T.
You got to be careful. This guy here, square root of 7 is a constant. What would you take the derivative of that would just leave you square root of 7? It's going to be the square root of 7 times t. And then, of course, plus Charlie. Okay, hopefully over here, not too bad. Antiderivative of sine of x, negative cosine of x, plus the antiderivative of cosine of x, sine of x plus Charlie. Antiderivative of e to the x, e to the x. Antiderivative of e to the negative x is negative e to the negative x plus Charlie. How many guys get all 4 of those right? Okay, definitely the next couple are going to push your thinking a little bit more. Have some conversation with the folks around you. Make sure you really have this under control. And watch those variables. Yes, sir?
position, you're going to take an antiderivative acceleration.
Sorry. Sorry. Who are you?
That would make sense to put 6 natural log x left.
Pi over t squared. Pi over t. Plus. Right up. You didn't finish. No, it's not. It's negative. It's fine. Over.
Over 2 squared. You have to keep 2 there. Yes. They're one and sinking. Oh, whoa. I made a mistake right there. Alright,
Oh, snap.
Oh,
you
I didn't see that coming.
The 6, for number 6, I said z instead of x.
I was just changing it.
Okay,
I was
so
like,
you're
yeah,
just
or
rewriting.
it's natural.
Yes.
What?
Okay, friend factor, we don't
He couldn't get that far. I messed up there.
I got this.
You're dumb. You're so dumb. I didn't.
know.
Bro, that tweet I sent you was so funny. Like I saw it, I was like, this is my
Yeah.
You never sent me a tweet.
Sorry.
Just end of it.
Oh, I thought he was also coming to hear about the tweet though.
No, I was getting over here from those sweet conversations. Okay, so we're getting here, not somewhere here.
Where?
This.
What was that? Did I do the same thing?
I put negative 2
Code 6 is where.
for this one.
Yeah, the 6 one's natural, the absolute key is great.
It's negative for both.
It's the next part that's not so good.
Wait, we did the same thing that we did over here. We did the same mistake over here.
Just put the code in there.
It's gonna be plus.
Because this is a property that is already
Yeah.
negative.
Oh yeah.
You're still
Yeah.
negative, so that's.
7 is 6, 11 is t plus pi over z.
Alright, everybody seems to be doing really well. Number 5, square root of z plus the natural log, absolute value of z plus Charlie. I'm going to be ruthless with your variables. Number 6, antiderivative 1 over x, natural log of the absolute value of x. Antiderivative of negative 1 over x squared has to be positive 1 over x plus c. All right, now this one I want to make sure I want to get all the brains on just for a second here. Way back in the last unit, right before Thanksgiving break, when we worked with integrals, integrals had some nice properties that you could use. Things like distributing the integral. Anybody remember doing stuff like that? You'd like distribute the integral, and you can do that in 2 cases. Addition and subtraction. And those are the only times. So if you wanted to, you could rewrite this one as 6 over t dt minus the integral of pi over t squared dt. I want to make sure you guys at least get this part in your notes. We're going to start doing a lot with the integral just like we did a lot with the derivative. So what I'm doing right now, I'm distributing the integral to both of these guys over here. Each of them gets the integral sign, each of them gets the dt. Now 6 over t isn't in the list. Now I know a lot of you guys you found it anyway, but for those of you that are struggling, there's something else you can do. There's some other property of integrals that you could use here. What do you remember?
I don't know what it's called, I don't know if it has a name. But you could say that, you can also say that 6 over t is equal to 6 times 1 over t.
6 over t is the same as 6 times 1 over t, right? A little bit of algebra.
Yeah.
There's also something else you can do with the 6. what could you do?
Take it out.
Flip it upside down.
You can take that 6 out in front of the integral. So you can say this is 6 times the integral of 1 over t dt, and I bet everyone knows exactly what this is. Right? And most of you guys probably knew it back over here, but if you needed to break up the integral as 2 separate integrals, and if you wanted to take the constant out, that's going to be okay. You could then, of course, also do that over here. The pi over t squared, don't sweat the pi. Just take the pi out, minus pi times the integral of 1 over t squared dt. Now, if I asked you what's the antiderivative of 1 over t, everybody knows? Oh, so awkward. It's 6 times the natural log of the absolute value of t. The antiderivative of 1 over t squared?
Plus
Positive 1
divided by x.
Mm-mm.
over pi over t.
We've got this negative. I already took the negative outside.
Positive pi over t.
Careful. The negative and the pi already came out of the integral. What's the antiderivative of 1 over t squared? It would have to be negative 1 over t. And I know, like, friends over here are like, but wait, that's what I had on my paper. No. Look at what I've got versus what you had over there. You've got negative pi times this negative 1 over t. Those guys are going to multiply together to give you a positive. So this will be 6 times the natural log of t plus pi over t plus c. And this last one, what is this? Negative 2 cosine of x minus 1/2 cosine 2x plus c. Is everybody okay? We get this under control? All right, here's what I want to do for the next 10 minutes or so. I want to give you an opportunity to, we'll call this challenge by choice. All the problems that you guys have done so far fall very nicely into these basic integration rules. The next batch that we're going to play around with do not fall into these basic integration rules, and they're all going to require some amount of fancy footwork when it comes to calculus and algebra. And I'm going to set my timer so that when it goes off in 10 minutes, we're going to stop wherever we are. And let's just do it. All right, antiderivative 1 over the square root of x plus the cube root of x. Neither of those show up in this list of integration formulas that you need to know. But there are some things that you could do that might make life a little bit easier. For example, how about rewriting this? Rather than 1 over the square root of x, another way you could rewrite 1 over the square root of x? That would be legal.
X to the power of negative 1/2.
How about x to the power of negative 1/2? Is that legal?
T.
We've not changed anything at all. Okay, plus cube root of x. Cube root of x, what is that? X to the 1/3 dx. Now here's the thing. Neither of these show up in your list of integration formulas that you should just know on sight, except they kind of do. Because what you've got is you've got your power rule that says the antiderivative of x to the power, you add 1 to the power, and you divide 1 by the power. Divide 1 by the new power. So in this case, this first one, n would be, what, negative 1/2? The power rule says add 1 to that power, so x to the negative 1/2 plus 1 times 1 over negative 1/2 plus 1. It's ugly, I know. Plus this guy over here, the antiderivative of x to the 1/3. Now n's 1/3, we're going to make this x to the 1/3 plus 1 times 1 over 1/3 plus 1 plus Charlie. Totally ugly. Totally ugly.
Could we leave it like this?
And we're not going to leave it like this. On the free response, it would totally be okay to leave it like this. But on the multiple choice, you're not going to see it this way. I'm going to hide it. Legal things that I can do to hide this. Things that you would expect I would do to hide this answer from you.
Negative 1/2 plus 1.
Right, negative 1/2 plus 1 is going to be, what is that, x to the 1/2 power? Which means over here, negative 1/2 plus 1 is 1/2. And I've got 1 divided by 1/2, so 2. plus this guy over here. X to the 1/3 plus 1 is x to the 4/3. 1 divided by 4/3 is going to be 3/4 plus Charlie. Right, so it was a matter of rewriting each of these so that I could use my power rule and go from there. All right, now something else I could do to hide this, rather than 2x to the 1/2 power, how about 2 square roots of x? Rather than 3/4 times x to the 4/3 power, how about 3/4 times x to the, how does this work?
It's in the, x to the fourth.
The fourth cube x. Oh yeah.
Okay, cubed root of x to the 4th power. Okay, plus c. Now I am pretty convinced that a lot of you all are going to be able to go straight from here, right over to here, right? But if you need to do the side work, do the side work. All right. Let's talk about problem number 2. In the world of integration, we have no rules, we have no formulas, we have no shortcuts when it comes to multiplication and division. There's a whole unit in Calculus BC dedicated to problems that require multiplication and division. And we're going to hit that in the spring. Right now, whenever you see a problem that involves multiplication and division, what you need to do is you just need to think about algebra trickery. So like legal algebra things you could do here to make this easier. Lewis, what do you say?
The x squared from the bottom, you bring it to the top by multiplying x to the negative 2.
Okay, and I've heard you and other people tell me to do that before. You bring it like x squared plus 4x times x to the negative 2, and then you've got to do like this weird distributing thing. Legal.
Oh, but you could
do what?
You could do x squared over x squared plus 4x over x squared.
Right? How about just make it x squared over x squared plus 4x over x squared. Now be careful with the notation. I'm still keeping this integral sign because I haven't found the antiderivative yet, and I'm still keeping the dx. Now what?
Now you just pick one. Like give x squared over x squared equals 1.
Okay, x squared over x squared is 1 plus.
You take out the x from 4x and you keep an x from the denominator.
Okay, plus 4 over x dx.
That's what.
And I bet most of you guys are able to look at this now and you know what the antiderivative is. If you're not able to do that, then break it up and say it's the antiderivative of 1 with respect to x plus the antiderivative of 4x with respect to x. What do I know that has 1 as a derivative? This is going to be x. Plus, what do I know that has 4 over x as its derivative?
4 times.
This is going to be 4 times the natural log of x, and of course plus Charlie. And for those of you that are like, I could have gone from here to here, do I have to hit this middle step? No, you don't have to do the middle step. I just wanted to like show it so we were good. Everybody okay? All right, show me what you can do. I want you to see, try number 4. If all goes well, we're going to hit 4 and 6.
Oh.
Remember, we have no rules, we have no formulas when it comes to multiplication and division. You're always going to need some algebra trickery. I'm seeing a whole lot of people be successful with rewriting square root of x as x to the half. Rewriting 5th root of x squared as x to the 2/5. Now, if you're going to make a mistake, here's where the mistake's going to come in. A lot of folks, and not necessarily right now, are going to say, oh, I know how to find the antiderivative of x. It's 1/2 x squared. I know how to find the antiderivative of x to the half. I add 1 to the power, divide by the new power. But they're missing the fact that there's a multiplication symbol here. There are no rules. There are no shortcuts right now that involve multiplication. You need to do some algebra. And the legal algebra here, I can combine this x times x to the half. I can rewrite this as, what is this, x to the 3/2 power plus x to the 2/5 power dx. Now, if I want to find the antiderivative, I've got addition. I could, if I wanted to, write this as x to the 3/2 with respect to x plus the antiderivative of x to the 2/5 with respect to x. You didn't have to break it up that way. This guy here is your power rule, where n's equal to 3/2. This guy here, power rule, n's equal to 2/5. Power rule says, okay, for the antiderivative of x to the 3/2, what do? Add 1 to the power. So 3/2 plus 1 is 5/2. Divide by the new power.
2/5.
So 1 divided by 5/2 has to be 2/5. Plus, find the antiderivative over here. X to the 2/5, add 1 to the power. 2/5 plus 1, 7/5. Divide by the new power is going to be 5/7. X to the 7/5 plus c. And if you want to show off your radical rules, x to the 5/2 just means square root of x to the 5th. X to the 7/5 means 5th root of x to the 7th plus c. Both of these perfectly good, perfectly acceptable answers. All the friends are okay? David, you feel okay? Good. All right, last one. Show me what you guys can do at number 6. Six. Remember, there are no shortcuts. There are no integration formulas that involve division. It's always going to come down to algebra cleverness. So I've seen a handful of folks that saw that x squared minus 4 in the numerator and said, okay, I can factor that. So 2 questions. Number 1, is that legal? Is this better? Legal for sure. Better? Why? What can you do now that you couldn't do before? So Les, what can you do that you couldn't do before?
You can cancel out the, you can not technically cancel out, but x minus 2 and 2 minus x will turn into negative 1.
Right, x minus 2 and 2 minus x, these guys are opposites of each other. And so when they cancel, it leaves behind that negative 1 that you have to multiply by. So what you've got now is the integral of x plus 2 times negative 1, which is really the same as the integral of negative x negative 2 with respect to x. What do I know that has a derivative of negative x? Negative a half x squared minus, what do I know that has 2 as its derivative? 2x plus c. Everybody feeling pretty good about this? It's just going to take some practice. The homework is going to be exactly like this. Just some that are really straightforward, some that are going to require a little bit of manipulation. At this point, we're going to turn off the video and